All right, everyone, in this video, we're going to talk about how to detect spam with naive Bayes and test using k-fold cross-validation. All right. Now, why would we want to use naive Bayes for spam detection? Well, naive Bayes spam classifiers work by correlating the use of tokens, typically words, with spam and not spam emails, then using Bayes' theorem to calculate a probability that an email is or is not spam. Okay? The reason why it's used is because it gives low false positive spam detection rates that are generally acceptable to users. And it's been in use since the 1990s, and it's still in use today. So pretty reliable method for spam classification. Now let's dig into some code and see how we can actually do this with some Jupyter code. Okay. So in order to classify email as spam or not spam, we're going to first train a classifier using sklearn naive Bayes, and then we're going to test it using k-fold cross-validation. And we're going to describe what that's about here in just a second. But let's start out by loading some email messages into a pandas data frame with each message classified as either spam or not spam. All right, so we've got a couple functions here. We've got a function which is just going to read files, all the files out of a directory. And then we have another function that's going to read a data frame from the directory, okay? So basically we're going to pass a directory into this function, and for each file name in that directory, it's actually going to read the files one at a time using that function, okay? All right, so we're going to start out by defining a data frame, a pandas data frame, with message and class. And here you can see we're appending the spam emails into that data frame. And then next up, we're going to append the not spam emails. And if we do all that, and then we take a look at the head of this data frame, we can see the first 5 records here. So we have an email, we have the class of it, spam, and what the message actually is. So if we just kind of poke in here, fight the risk of cancer, sounds like spam. You know, I thought you might like these, slim. Okay, so we've got some kind of spammy stuff going on here, and the classification, at least at first glance, would seem correct for that. Now our next step is to use count vectorizer to split up each email message into a list of words and their counts. All right, so we're going to say vectorizer equals count vectorizer, messages equals data message dot values, and then we're running the fit transform function from vectorizer on messages to get us these word counts, okay? And next we're going to create a multinomial naive Bayes classifier, fit it with the message word counts and target values, which would be the classification of spam or not spam, right? So here we're defining our classifier, multinomial naive Bayes, that's what the NB stands for. Here we have our classes of the class values from our data frame. And we're just going to say classifier fit. And here we have our word counts and the classes. All right. And now for the moment of truth. We're going to test our spam detection classifier using 2 pretty clear-cut examples. Okay, so I just came up with 2 test messages here. The first one's got $3 signs, the word free, cash, Nigerian prince. You'd be hard-pressed to find a more spammy message than that. And then another example would be, hey, what did you think of last night's episode of Friends? So nothing particularly spammy about that, hopefully. But let's see. Test message counts. We're going to run the transform method from vectorizer on those 2 messages to get our counts. And then we're going to say classifications equals classifier, which is our multinomial naive Bayes classifier, to predict off of those test message counts. Okay, and we're going to take a look at these classifications, and we get an array back which is showing that the first message is spam and the second message is not spam. So our spam classifier does appear to be working. Now, let's go the extra mile here and just use k-fold cross-validation to objectively measure the accuracy of this classifier by splitting our data across 5 different folds. Okay, so we're going to import cross-validation score from sklearn.model-selection, and here we have scores, okay, equals cross-validation score, the classifier, the counts, the classes, and again it's 5-fold. Okay, so first I just want to look at the scores for each of these 5 runs, and we're getting a 96, 97, 94, 94, 94% accuracy for an average of 95% accuracy. So what that means is, just using this alone, this simple little naive Bayes classifier, we're able to say, hey, you're gonna correctly identify more or less 19 out of every 20 emails as spam, with a false positive of 1 out of 20. Not bad, given the simplicity of this method. Okay, so I hope you enjoyed this. Thanks for watching, and I'll see you in the next video.